Hello, today's video lecture covers Chapter 4 from your textbook, which is Standards, Measurements, Recipes, and Formulas. So the objectives on page 47 of the text, as well as here on the screen, upon completion of this chapter, you should be able to define standards. What is a standard recipe? Standard yield, standard portion, and standard presentation. You will be able to explain the difference between a standard recipe and a standard formula, write a standard recipe and a formula, convert units of measure, and convert standard recipes and formulas to a new standard yield. So to be consistent, standards are created to serve excellent food all the time, and an operation needs to have standards in order for customer satisfaction. So what are standards? As stated on page 47 of your textbook, quality standards are rules, policies, or statements set by managers to help employees perform quality tasks, produce quality products, and provide excellent service. When preparing meals, developing recipes, answering the phone, greeting customers, serving customers, taking inventories, performing yield tests, determining portion controls, determining plate creations, closing out the cash register, cleaning and sanitizing equipment, hiring and firing employees. The list goes on and on. These are all different types of standard operating procedures. Establishing standards allows for efficiency and cost control, because when there are no standards, there is little consistency, and the quality of the task performed and the cost of doing business are likely to increase. So, customers want to experience food and service that is great at every visit. Common standards are here on the screen. Basically, you have your standard recipe, your standard yield, standard portion, and standard procedures. So a standard recipe is a written formula. It's used to produce food and beverage items that are of a consistent quantity and quality. These are more often referred to in the baking and pastry kitchens as standard formulas. Both of these are discussed in detail on page 48 of your textbook. But basically what it comes down to are standard recipes are used to prepare culinary items, and standard formulas are used to prepare baking and pastry items, in which the measurements can be more precise. The ingredients in a standard recipe can be adjusted to meet the chef's taste. If the ingredients in a standard formula are adjusted, it may lead to the product failing for one reason or another, like maybe too much chemicals in the cake or in the muffin, too much yeast, not enough yeast, a little bit too much salt, will cause a catastrophe in the bake shop. So, a lot of people determine that baking and pastry is a science and culinary is an art. Okay, now what are the advantages of a standard recipe and formulas? Well, one of the biggest advantages of having them is consistency of the product, which ultimately leads to customer satisfaction. There's nothing worse than going to a restaurant and enjoying a fabulous meal, only to come back the next week and repeat the experience to find out the food is completely different or subpar from the week before. We need to make sure that the food is the same no matter who's cooking. The standards have to be the same. Whenever the standard is deviated from, it will be easy to recognize, and there will be an opportunity for immediate correction. This is very similar to when you were taking your practicals in your lab classes. Your chefs knew when you deviated from the recipe because of maybe the sweetness, the saltiness, the color, or the doneness of the product. And they could tell you, okay, well, you didn't cook it long enough and you probably got points deducted for that particular area. These are the chef's standards. So standards are put into place to help everyone in the operation achieve success. They are often called SOPs in the industry, Standard Operating Procedures. A standard recipe or formula is composed of three different areas: the standard yield, the standard portion, and the standard procedures, as we've said before. The standard yield is the quantity of the product the recipe produces. This is the amount for the total recipe. The standard portion is the quantity or size of the product. It can be measured by weight, volume, size, count, size of container. How can an employee do this? As it says in your text, using proper tools like a scoop, ladle, counts, or measuring device is the first step to improve consistency for customer satisfaction, and this aids in ensuring a business profit. Bars want to keep consistent, so they use jiggers instead of free pour. The main idea is serving the same quality and the same quantity of food to each person who orders. And then, of course, lastly is standard procedures. These are performing tasks in the same manner, same way, every time. So when you see the MOP, or the method of preparation, the plate or beverage presentation, sameness is the takeaway from this task. So when we're reading and writing standard recipes, formulas have a lot of advantages, like predetermined item cost and provision of a plan of preparation, and elimination of employee preparation decisions. This also eliminates dependency on specific employees. If someone quits and they want to take all their recipes with them, or just the ones in their heads, it won't matter because you have all the recipes written down and kept in an SOP journal for future references. Nowadays, a good idea is to keep the information of all your standards in the cloud for safety, and then also keep it on a drive somewhere for easy accessibility. So when writing a recipe, these points need to be considered. First, you have your standard recipe, which is the formula name. These are organized by primary ingredient. They're also followed by modifiers, like lasagna, meat and tomato sauce, lasagna, vegetable bechamel. Standard yield and standard portion. Yield stated both in quantity of the product, like 3 gallons, and number of stated portion size of the products produced, like 64 6-ounce portions. Continuing with ingredients, these must be listed in the order of use. When ingredients are used more than once, list the total quantity where first used, followed by the word divided. Be clear when listing quantities. 1 6-ounce semi-sweet morsels. Spell out unit of measures to avoid any doubt. If the ingredient needs simple preparation, list it after stating the quantity, like a half a cup of celery, finely chopped. List all your equipment and the major tools required. List these steps in chronological order, in the order they're going to be used. Use short, concise statements. Keep it quick and to the point. In the procedure section, listing groups of ingredients and then method of combination. Listing various components and list those steps separately. Stating exact or approximate mixing method times, like put on the grill for 3 minutes on each side, or char for approximately 7 minutes on one side. Bake for 35 minutes or until the touch of the middle springs back and there are no moisture droplets in the center crack of the pound cake. Emphasize any special directions or precautions for the product. List serving recommendations, garnishes, serving temperatures, how to store, and storage instructions. When it comes to the measurements and their equivalents, use the appropriate standards from the U.S. standards, like the U.S. standards in weights. You'll notice here that pound is abbreviated by LB. A lot of times you're going to see a pound sign next to that. It is acceptable to use whatever you decide, but make sure that it is universal. You're going to be using it in all of your recipes. And whoever is preparing the meal knows that for an ounce, the number is underlined under the ounce to create the ounce. And 1 pound, 4 ounces, the 4 might be underlined. Instead of putting 1 lb in 4 oz. Sometimes that 4o might look like a 40 to someone looking at it very quickly. So that's why we use different types of terminology when we're creating standard recipe cards. When it comes to volume, gallon is usually GAL, quart, QT, pint, PT, cup, C, fluid ounce, FLOZ, tablespoon, capital T, BSP, and teaspoon is usually in lower caps, TSP. When it comes to metric, we use in weight, gram is G, and kilogram is kg. In volume in metric, we use milliliter ml, and liter is L. In Appendix A, it will show you how to provide measurement conversions from one system to another. Please read up on that and become familiar with that. When converting standard recipes, the first thing is calculating a conversion rate factor. So, when we have a recipe conversion, we're changing a recipe's standard yield to meet the production needs. The same procedure is used whether increasing or decreasing the standard yield. So we have a few steps when we're doing this, and the first step is calculating the conversion rate factor. A lot of times you'll see this as new over old, n divided by O. We'll be doing this in class as well. The desired standard yield is divided by the original standard yield, and this equals the conversion rate factor. So an example, to increase a standard yield of 75 by the original standard yield of 30, we'll take 75 divided by 30, and that gives us a conversion rate factor of 2.5. We can then take each ingredient and multiply it by 2.5 to get the exact amount we need for each recipe. For decreasing, it's the same way. You take your desired standard yield, which would be your new standard yield, and you divide it by your original standard yield, which would be your old standard yield. So 15 divided by 30 would give you your conversion rate factor at 0.5. So then you would multiply each one of your ingredients by 0.5. So let's show an example of this. We multiply each one of the conversion rate factors by each of the ingredients in the original recipe. When we have tomatoes, for 4 pounds of tomatoes, we're going to take it and multiply it by a conversion rate factor of 2.5, which we just did in the previous slide. And that gives us our new ingredient quantity of 10 pounds. 10 pounds of tomatoes would be needed to produce 75 portions. Now, if we want to decrease the portion size, we would take our tomatoes, take our ingredient quantity of 4 pounds, we multiply it by 0.5, and that only gives us 2 pounds. So 2 pounds of tomatoes would be needed to produce 15 portions. The baker's percentages illustrate standardized relationships between foundational ingredients. These foundational ingredients include flour, water, salt, and yeast. Now, this isn't the only ingredients we use in baker's percentages. Of course, we have sugar and we'll have other types of ingredients, but they're all based on one particular item, and this is the flour for the most part. Okay, in a baguette formula and a standard yield, we're going to be making 16 loaves. Now, we're given the percentages, but we're not giving the amounts. So depending on how many pounds of flour you're going to be using, in this instance we're using 10 pounds of flour, and that's going to be 100% of our total recipe. We're also given water at 66%. So we take the flour amount, which is 10 pounds, and we multiply it by 0.66, and this gives us 6 pounds 6 ounces of water. We're going to do the same with salt. We're going to take 10 pounds of flour, which is our 100%, and we're going to times it by 0.01, because that's 1% of 100%. That's how much salt we need in this recipe. That gives us 1.6 ounces of salt. For the instant dry yeast, we need 8%, or actually 0.8% of 100%. So we're going to take our 100%, which is 10 pounds of flour, and we're going to multiply that by 0.008. And that gives us 1.28 ounces of flour. So it's not much difference. It's just more of a foundational formula than it is a recipe. So whether you are increasing or decreasing a standard formula in the baker's percentage, flour is always going to be 100%. And the individual baker's percent illustrates the relationship of all other ingredients in the standard formula. For the most part, we use wheat flour as 100%, but there are instances where you won't be using wheat flour, you might use rice flour, and in this case, we would need to change up the recipe and make it more of a recipe as opposed to a formula. The reason why we use baker's formula for 100% flour is because of the gluten content. We know the ratios that the gluten is able to hold, the weights that the gluten is able to hold. And so that's why we can use a really precise formula for the different types of bread formulas, and cakes and muffins as well. Okay, so that's the end of Chapter 4, Measurements, Recipes, and Formulas. Please read Chapter 5 and be prepared to work on formulas and cost cards when we come into class next week. Thanks so much for watching.